for the last part of the lab, part E, we're going to focus on Ohm's law and measuring the voltage and current through a resistor. And so it's asking to build a circuit that allows you to do this, and it's going to look a lot like the single bulb circuit because we have one element, the resistor. And we're actually going to be comparing it to the voltage and current measurements we took with the single bulb. So again, the power comes out, goes into the resistor, out of the resistor, and into the power supply again. But there's one small problem, is that the current reads 0.01. And even as I decrease, it eventually goes to 0, but that doesn't give us a lot of information. And the issue is that the current through this resistor is actually smaller than the meter on the power supply can read, so we're going to have to introduce another meter. And that meter is, this guy is also a multimeter, but we use it as a current meter. And whereas the voltmeter was put in parallel with something, because things in parallel share voltage, the ammeter is going to have to go in series with something, because things in series have the same current. And so to do that, we're going to have to break our circuit. And so what we're going to do is the power goes out, and now instead of going directly into the resistor, we want it to go into the ammeter, the current meter, and then out of the current meter and into the resistor. And this is going to allow us to measure the current through the whole thing, similar to putting a flow meter on a pipe to measure water flow through a series of pipes. So to that end, we're going to turn on our current meter. It is already measuring DC current, spitting out way too many digits, but we'll make do. And then the symbol for an ammeter is a circle with an A in it, whereas the symbol for a voltmeter is a circle with a V in it. And you can use those to draw the circuit that we want for part one. So now we're going to do similarly what we did with the single bulb and take a given voltage and measure a given current. So we're already set to 4 volts, so the current given, which is 5.5285, and this is in milliamps, which is 1,000th of an amp, and so it's something to keep in mind to keep a little m by your amp like it has here. So then we're going to turn this up to 6 volts, and we're going to get 8.3040506 07 3, and then we're going to go up to 8 volts, and we get 10.959601, and then we're going to go up to 10 volts, and we get 13.566, and we're going to go all the way up to 12 volts, and we're going to get 16.338, all in milliamps. Again, you'll be given this data to manipulate on your own, but I just wanted to show the circuit and see how we did it. And that is it for the electric circuits lab. Good luck, and I will see you guys next week.